In this lecture, we're going to further build upon object-oriented programming and move on to the concept known as inheritance. Now, let me ask you a question. Why do you think they call it object-oriented programming? I mean, why don't they call it object-oriented science or object-oriented theory or something like that? Well, the reason why they put the word programming in there is because it's a way of programming. It's a better way of programming as opposed to an older approach, which was to dump all of the code into one file and just have methods all over the place in that one file. It would just be a very, very large file full of code if we were to use an older programming language. But the new and proven way of better organizing our code is called the object-oriented way of programming. And that's what Java is based off of. And that's what I'm teaching you here. Object-oriented programming is a way to organize our code. Rather than having all of the code in one file, we split the code into multiple files that make logical sense. So in the previous lesson, what we did was we created a class called animal, and we gave it some instructions for how the objects will behave. And we created some other classes such as fish and bird. And in the zoo class, we had the main method, which really is the entry point. Every application needs an entry point, and the main method was the entry point for our application. So when we hit run, this is where the program starts, and it would go line by line and basically create our objects based on how we organize our code. So we are providing instructions on line by line how the object will be created and what methods we want invoked on that object. Right. So again, remember, this is a variable that points to some object that gets created in memory when this part runs, and then it goes to the next line, and then it invokes the eat method, moves to the next line, creates a new object, assigns it to a variable of type bird, and then based on what the specification in the bird class, we're able to access the fly method, so we invoke it here, right? So these are, at the end of the day, instructions on how our application should be run, and we have code nicely organized in these files. Okay, great. So let me build upon the idea of code organization in object-oriented programming. Now, notice how in the animal class, I've defined two methods, eat and sleep, that pretty much all animals in a zoo do. And this behavior of eating and sleeping is applicable to the bird as well as the fish. I don't know if this fish sleep because I've never seen their eyes close, but definitely the birds, I think they sleep. But anyway, this behavior is applicable to other animals, right? So how do we better organize our code so that other classes can take advantage of these two methods as well? The way to do this is through inheritance, right? Inheritance is another way of organizing our code, and that basically is exactly what it sounds like. One class inherits behavior from another class. And the best way to do this is to make sure that the class that is wanting to inherit that behavior is actually a breed of the parent, right? So basically the bird is a kind of animal, right? It is an animal. And a fish is also an animal. So it makes sense for the bird as well as the fish to be inheriting behavior of the animal. So the terminology here, I'll introduce some terminology to you. The animal class is referred to as the parent class. And these two classes will be child classes. So for bird, in here we can type in extends animal. And now the bird is a child class of animal. The animal is also referred to as the superclass. Another name you'll hear is that the animal is the base class. It contains base functionality. And the bird class is a subclass. It contains sort of sub-functionality. So Eclipse is complaining here, showing a little red squiggly line indicating that there's an error. So if we hover our mouse over it, it's saying that implicit superconstructor animal is undefined for default constructor. So let me translate that for you. It's saying the way to create a bird is different than the way to create an animal. So basically the instructions on how to create a bird, right, the bird constructor is different than the animal constructor. And if we're saying that the bird is an animal, right, it extends an animal, it inherits functionality of an animal. If you're saying that the bird is an animal, then how can it have a different way of creating a bird? A bird is an animal. It should be created the way animals are created. So we need to basically define a constructor in bird that is compatible to the one that we have in animal. So by default, if you remember, I mentioned this in the previous lesson, there's a default constructor in every class that would look like this, right? It would have the same name as a class name, and this exists by default in all classes where there is no constructor defined. But when we extend a class like this, that default constructor won't work anymore, right? Because there's a conflict between the ways in which an animal is created and the way in which a bird is created. All animals require, if you go back to the animal class, these parameters to be passed in, right? So a bird cannot possibly be created without these parameters. So in the bird class, we need to define a similar constructor as animal. So the way we do this is we can hover your mouse over the bird class and click on add constructor, and it will pretty much automatically fill that in for you. I just got rid of some comments there. And what it's doing is in the bird constructor, it's calling super, which means it's calling the super class's constructor, right? To create a bird object, we are propagating those values over into the animal because a bird is an animal. It can't possibly be created on its own if it's extending from the animal class, okay? So hopefully that makes sense. But if it doesn't, don't worry. We'll be doing this plenty more in the course, and it'll make all the sense pretty soon. So if we come over to the fish class, the fish is also an animal. So let me extend animal here. And now the fish is a child of the animal, and it should inherit all of the base functionality that is in animal. So if I hover my mouse over into fish, I can add the constructor here, and it will basically call the animal's constructor, right? So when we create a fish object, we pass in the values over, and those values will basically be carried over into the super constructor to create a valid animal object, right? So let's test this out. Let's go back into the zoo and notice that we can no longer create a bird like this, right? When we don't have a default constructor anymore, we have a specific constructor in the bird class. So we need to give it some values to properly instantiate a bird instance. So I'll say that this bird is 3 years old. Its gender is, we'll say it's a female. And let's say it's a 10-pound bird. That sounds kind of heavy for a bird, but not sure how heavy birds are, but doesn't matter anyway. And then we can invoke the method that's defined in the parent class of this bird. So bird1 dot, we can make it eat now. All right, this bird is now also capable of eating. We can also make this bird sleep. All right, these methods are accessible to us now. Now, can you guess if we try to make, for example, this animal object, or animal variable, I'll refer to it. If I call animal1.fly, do you think it's going to work? Of course not, because the fly behavior is part of the bird class. Okay, it's sitting here, and this is not visible to the parent. And thank God that it's this way, because it's a much better way of organizing the code. The parent should not be able to inherit from the child. That's sort of backwards. The child always inherits from the parent. So basically, again, what is a class? It's a specification. It's a design of how things ought to be. And a bird needs to, if a bird is an animal, it better follow the same specification because it is an animal. That is why in Java, everything that all the method visibility is driven by the variable type. So let me show you what I mean by that. this animal, one variable, is a variable of type animal. So the methods that are visible to this particular variable are the methods that are defined in its type specification. So the animal is its type. The methods that are defined in that animal are the only methods that are visible to this particular variable. In the bird's case, the methods that are visible to it are all of the methods that are defined in its class, as well as the methods that are defined in the parent class. Okay, so this type, basically the bird specification. When we have bird extend from animal, the animal specification is sort of copied over, and that's why we had to conform to the animal, the way animal is created. That's why we had to define a similar constructor, and all of the methods that are in animal are basically copied over into this class because we are extending it. But luckily, we didn't have to type them out here. That's what this extends keyword does for us. So again, keep in mind that the methods that are visible to a particular variable are based on the type of that variable, right? And that is animal. All right, so I think now is a good time to calibrate what we've learned so far. I know we've covered a lot of ground. We talked about inheritance and classes and objects and constructors and so on. But I don't want you to miss the whole point. The whole point is code organization. That's what object-oriented gives you. Newcomers to this field often get caught up in the intricacies of creating objects and interfaces, and there's a lot of other concepts that you'll learn. But I don't want you to miss the entire point, and that is to organize your code better. That's what object-oriented programming provides you. That is why we decided to extend the animal class. We made bird extend animal because a bird is an animal, and if we didn't have the ability to extend animal, we'd have to copy over the method. For example, in the animal class, we'd have to copy over these two methods into the bird class, right? We'd have to paste them here, and there would be code duplication going on if I chose not to extend animal. But extending animal basically allowed me to write cleaner code, right? So this is what object orientation is all about. It's about better organizing your code. And when in terms of a computer, it doesn't care what language you use or what framework you use to write. It's just you just have to give it instructions, and it will execute those instructions sequentially. So back in the zoo class, when our application starts up from the main method, it just goes line by line, executing all of these lines, creating the objects that it needs, and basically running the application. But just keep in mind that these are just files, and when you run the application, that's when the objects come to life and they do things, right? And that's how the application runs. I know it's a very basic point, but I want you to keep that in the back of your head when you're first starting off programming in an object-oriented language. All right, so I wanted to introduce two other ways of better organizing your code, and that was interfaces and abstract classes. But I think now is a good time to end this lesson because it's already getting pretty lengthy. So I'll introduce you those topics in the next lesson. All right, thanks for watching. I'll see you soon.